So for today's video, we're going to talk about the next type of rock, which is sedimentary rock. Sedimentary rock makes up about 75% of Earth's surface because they're actually formed near the surface and on the surface. Yesterday we talked about how igneous rock made up the majority of the crust of the Earth, but the sedimentary rock makes up the topmost layers of the crust, which we also call the surface. This means that they form in much less intensely heated environments compared to if they were deeper down below the Earth's crust. And they form from a thing called sediment instead of the magma that we talked about yesterday with igneous rocks. The sediment is a naturally occurring material that is made of broken down rock by weathering and erosion, and it's transported by the movement of wind, water, or ice, or anything that can carry it. And these sediments are then laid down in a process known as deposition, and then they're compacted and cemented over long periods of times in order to form layers of rocks. And we'll go through these processes in more detail in this video.
I was walking my dog on the beach when I noticed that the cliffs are made of horizontal stripes of rock. But what causes this? To understand this, we need to explain how sediments are formed and explain how sediments are turned into layers of new rocks. Existing rocks can be broken down into small pieces or sediments in a process called weathering.
Weathering is the process that breaks rocks down into fragments and eventually sediments. Soil formation depends on sediments from weathering, and those same bits make up sedimentary rocks. Weathering can even change the Earth's surface over time. Mechanical weathering breaks down rocks without changing their chemical composition. Forces like growing plants, expanding ice, lightning, and mineral crystal growth can all cause mechanical weathering. Plant roots grow into cracks of rock where they can find water and nutrients. When these tree roots get big enough, they'll force the concrete apart. Ice can do the same thing. In cold weather, water freezes and forces rock apart, creating all sorts of pressure. Then it gets warm, and that ice melts, leaving cracks and making the rock weaker. Chemical weathering happens when water, air, or other substances react with the minerals in rocks, soil, and building materials to change their chemical composition.
The sediments formed by weathering can be moved away by water, ice, wind, or gravity. Eventually, sediments settle in one place. For example, they may sink to the bottom of the sea. This is called deposition. More layers of sediment are deposited on top. Over millions of years, the weight of the layers above compress the ones below, and they harden into sedimentary rock in a process called compaction. Sometimes another substance seeps between the sediments and hardens, sticking or cementing the sediments together. The whole process leads to the formation of horizontal layers of sedimentary rock.
So just to recap the video, this process starts with step number 1, which is weathering. And as we talked about, that can either be physical or chemical. And then step number 2 is the erosion, which carries that broken off material into a stream or by a mudslide or flash flood or things like that, natural events that can carry the material. And then once that is done, it is deposited in the third step of deposition. And then our fourth step is when it gets compacted down. And our fifth step is when that compacted material gets cemented and then forms a rock from that. And that process can take hundreds of thousands or millions of years.
Now we're going to talk about the environments that deposition commonly occurs in. So deposition is where the places that sediment is then carried and deposited. So the geographical location and physical characteristics of the area will determine the type of sediment that is commonly deposited there. A lot of what determines what will be deposited where is the energy in the environment that these materials will be deposited in. Generally, the higher the energy of this depositional environment, meaning the faster that the mudslide or the stream is moving, the larger the grains that will then continue to be carried on to different places. Anything that is too heavy to be carried will be dropped and therefore deposited in the ground.
The fact that faster moving waters that have more energy can carry heavier sediment is shown in this animation. You can see the fastest water at the top carries all but the biggest rocks. But as you make your way down, the water slows and the water can no longer carry the gravel, so it is deposited. Next, it slows down so much that sand grains are dropped. Then finally, those very small clay-sized particles get deposited furthest down into the calmer water. This deposition leads to stratification, which is the layers in the sedimentary rock. A single layer, known as a strata, is a horizontal band that contains the same kind of rock, the same color, and the same size of sediment. These layers, strata, are formed over the course of hundreds of thousands of years or more due to the buildup of deposited material. The new strata are formed on top of the older strata, which cement and compact due to the older strata over longer periods of time due to the weight and the pressure of the new layers on top. For example, sometimes when you're driving on the highway, you can see horizontal lines in the rocks on the side of the roads. These are sedimentary rocks with stratification, and it is easy to see the layers that make it up.
So common features of strata include ripple marks, which are the recorded motion of wind and water waves on lakes, oceans, rivers, and sand dunes that is recorded in strata of sedimentary rock. And another common feature is what is called a mud crack, which is where the fine-grained sediments at the bottom of a shallow body of water are then exposed to air and they dry out. These mud cracks in sedimentary rock can mark the location of an ancient lake, stream, or ocean shoreline, and they can even record raindrops.
So we're going to have three main types of sedimentary rocks. We're going to have clastic, chemical, and organic. The first one we'll go over is clastic. That occurs when there's rock and mineral fragments inside the rock, and these are known as clasts. This is an example of a very coarse rock, and you can see it has really sharp and jagged edges, these giant pieces of rock embedded in it. And then here's another example that doesn't have the jagged edges, but it has giant clumps of rock that are all more rounded. So these clastic rocks, as well as being coarse, can be medium, like sandstone, or they can be fine, like shale.
Chemical sedimentary rocks are formed when chemical reactions occur while water evaporates. So if there's a big salt water basin such as the Great Salt Lake, you will get salt deposits that occur over time as the water evaporates. So limestone is another example of a chemical sedimentary rock.
The last type of sedimentary rock we have is organic, which means they come from dead plants and animals. For example, we have this one that looks like oatmeal, but it's actually called coquina and is made of the remains of shells. Then we also, everyone should be familiar with this one, we have coal, which is actually made from plants and animals that died millions of years ago. And over time, that organic material compacted down enough in order to form that rock.